Thank you all for coming to this talk. Today, we're going to talk about functions, and in particular, functions as a service. And this talk analyzes this new compute model. It applies it to AI in order to present a solution that seems to bring strategic advantages when deploying AI services at scale. So during this session, it may feel like we're dancing a bit, moving through tools, new technologies, maybe even you might even see some new steps, like workflows or methods to work with AI. And for those of you that know salsa, you know that it starts with a step forward. So today, I'm going to start with some bold statements, but bear with us. I'm going to take a step back, and then me and AK are going to rehearse something through a live demo, which hopefully is going to go just fine, and to illustrate what we're talking about. So let me start with a step forward. Fast value prop. What does fast bring that more and more people are talking about? So I came with 3 reasons. Number 1 is faster to prototype, is faster to create services, because we work with code, with functions, just code, and we just push the code as it is. Second, never pay for idle. Fast platforms have the capability to shut down the parts of the system that are not used, so we don't incur any cost. And the third one is a low maintenance overhead. And that's because fast platforms usually take away the burden to create containers, keeping them up to date, apply security updates, auto-scaling the functions, deploy them in multiple regions. So, in other words, fast boldly claims that you'll find it easier to build more services and you're going to pay less. Now, this is a pretty bold statement, isn't it? So, allow me to take a step back and look at how developers are producing microservices today. A few years ago, we realized that microservices are better than monoliths because, in essence, they add flexibility and they simplify the dev experience. At the same time, it's also less risky to independently update parts of the system. And I would assume that many of us know what microservices are. A very high-level microservice architecture is in this slide. So the final solution basically consists of isolated pieces, which each with its own independent deployment lifecycle. Now, microservices used to be deployed in their own VMs, and then containers came, and it was such a revolution because we were able to correctly run multiple services in isolation in the same VM. Then Apache Mesos and Kubernetes, the container managers, came into the picture, and they made this nice API and beautiful API to deploy to thousands of VMs, as many microservices as we want with a beautiful API. However, this simple picture, we take it, we put it in multiple regions, we add monitoring, tracing, we pay for logging, and we add all these services. So it makes me wonder, did we actually really simplify a lot of things? Because it looks like, we have more things to care about. Like we don't just monitor the VM, we monitor the containers, we can monitor the container manager, and so forth. So this brings me to this chart, which is about how much it costs to run a microservice and the cost of goods sold. That's what the COGS stands for. There's 2 ways to look at this chart. First, my organization has allocated budget, and as long as I stay within that budget, I'm completely fine, and I can run as many microservices long running, it doesn't matter. The second view is my organization cares about the cost of goods sold and wants to know how much it costs to run a service. So the cost model for microservices is dependent on what? It's dependent on how many microservices I deploy, how many microservices I run, and then we add to this the cost for monitoring, alerting, and so forth. Now, when the traffic is unpredictable, spiky, how do we compute the cost of goods sold? If your manager asks you how much it costs to put the new service, what do you answer? Well, there's kind of 2, or it's a range. It's either I'm going to answer, well, I'm provisioned for 100,000 users, but I have less. So which cost do you want, the true cost or the actual cost? So I don't want to say that microservice architectures are wrong just because the cost model is not perfect. But I do want to bring into the conversation the aspect that there could be something better. And today, probably you guess, we're going to talk about functions. So let's observe how the cost of running microservices compares to the cost of running functions. On the chart, on the top right chart, you see on the vertical axis is the cost, and on the horizontal axis is the number of functions deployed. Now, the line is straight. Why? Because when I deploy functions, I actually don't pay for them. The only cost that I incur is shown in the chart on the bottom right, is when requests come in, and I also have a very fixed model for every function that I invoke, right? So this cost seems to be a little better. So why am I talking about this? So to make it easy for you, the reason why I spoke about this so far is I like to suggest, this is another bold statement, that when we start to build a new service, consider doing it serverless, because we may end up paying less, and if it's not going to be used a lot, then we can iterate faster. But how can actually serverless promise this? I think, here's just my answer. I think fast platforms just happens to have better premises. It handles code, which is a smaller unit of deployment and scaling than containers. And second is that it has this request-based auto-scaling, in the sense that if I have 100 users concurrently hitting my system, I'll have 100 instances of my functions deployed that are going to serve those 100 concurrent requests. All right. So let's make a step forward and talk about AI and FAST. You may be wondering, why so much talk about AI recently? And I like how Andrew Ng puts it in a very simple chart. Horizontal is the amount of data. And traditional machine learning algorithms wouldn't perform better regardless of how much data we would add. But in the recent years, and I would probably mention 2012, aka keep me honest here, 2012, AlexNet was AlexNet, the first network that neural network that actually performed really well for computer vision. 2014, 2015, deep speech.
Deep speech, yes.
Yeah, neural network used in voice. So we noticed that if we are able to train larger neural networks, our performance is much, much better. So it's much more fun, so we can actually do stuff with it. And hence, we're talking so much about AI. What's interesting to observe when starting to make AI apps, and I like it how Peter Norvig, the director of research at Google, puts it. With AI, we look at the programmer more like a teacher assisting computers in learning, rather than a micromanager that just imagine a program, starts at the top, runs all the way to the bottom. It's very deterministic. And it's interesting to know that we spent the last 40 years building up tools to deal and programs to deal with text, which is code, in a good way. But right now we're creating models instead of text, and we just don't have the tools to deal with that. And Peter Norvig goes on to say that we need to retool the industry. And he's talking about probably zeroing in to the model and maybe put a breakpoint on a neuron and see what happened and see if we can change it. And for the scope of our talk today, we're not going to go that deep, but we are going to touch on some new tools and workflows. Last quote I'm going to leave you with is Andrej Karpathy, which says that neural networks are not just yet another thing for software. He goes on to say it's a fundamental shift in how we write software, and calling it software 2.0. Please keep in mind these quotes when you see that we're experimenting with some tools that may be new for you. The goal of our presentation is to show how developer experience can be improved with these tools and processes, and how AI development could be made faster. So if these tools are maybe new, or it's the first time you see something, don't let your mind confuse you. Just please focus on the process and on the intention that we want to show here. As with dancing, you know, the more you practice, the better you get. So going forward, let's analyze how AI applications are built. At a very high level, this is just my view. You start with a process. You have an idea, you write some code, you experiment, and you iterate. As you do this, you use some tools. And today, we're going to see Jupyter Notebook in action. And this code needs to run in some compute. And there's, at the high level, two types of jobs. There's long-running jobs, which are used for training, and short or on-demand jobs, which are used for inference. And these jobs may run on the cloud in computers or on the client device. So I mentioned training versus inference. Training is about learning, inference is about answering. So inference is getting a new data sample, passing it through a network to infer an answer. In other words, or put it simpler, I have on my left two images, and I put the image through the network to infer on the right side if it's a dog or a cat. So inference runs faster than training, and also a neural network would process one data input at a time. So this logic matches very well with the fast model. There is enough code for a function, and each function processes one request at a time. If you look at my slide, I just put conceptually how an AI function would look like. It would first download and cache the model, and second, it will run the inference and return the output, whatever output of that inference is. And additional fast benefits, as I mentioned, is faster to deploy just the code, the model directly with the models in some cases. You never pay for idle, so you can experiment with as many algorithms as you want, and it's a low maintenance overhead. The question is, though, if I have an AI algorithm, do I have an application? Like what do I need to have a real application? And from what I noticed, real applications actually integrate multiple algorithms into workflows. And if I already have an existing algorithm and I build a new app, I might want to try to reuse existing functions or existing models. Sounds fair? So without further ado, let's go into the demo. So to illustrate how AI and fast work together, we simulated a real-world use case, a workflow. Me and AK have been given the wonderful task to create an intelligent content workflow to make it easier to build product catalogs, starting directly from photo shoots. So the user would upload the photos, they will be stored in a cloud storage, and in our demo it's going to be Creative Cloud. The cloud storage event will trigger a function in the background. The function then will invoke our workflow. We'll first check to see if the image was good, if it was blurry or not, or if it's interesting enough, if it's good enough to work. Then my task today is going to create a body crop function to crop from eyes to hips. And then we're going to go through an auto tag function that will extract the product SKU, whatever the subject wears, and maybe other tags. And then in the end, upload the final image to a product catalog so that it can be used. We also call this like content velocity. It just goes super fast. I'm going to reuse two existing functions. The image quality, I already had it, and the auto tag, it's in place. To make this demo, we're going to use an open source serverless platform, Apache OpenWhisk. We're going to use a composer from which is a nice project done by IBM Research that just allows us to put multiple functions together into a workflow. I'm going to show you this, so don't be confused if this is new. And then for editing AI actions and deploying, we're going to use Jupyter Notebooks. Okay, so let's go into the demo. All right, I've created this composition. Oh, okay. I've created this composition. Let me do. I'm into the IBM Cloud Shell, which is the OpenWhisk composer, and I created a composition called asset created composition, and let me zoom in. It basically shows the same thing that we saw previously. I first tried, like the workflow that I was just describing. Let me put this to work, and then I'll explain a little more. So I'll go into Creative Cloud, and I will upload a picture. All right, this one. Okay, the picture was uploaded. So behind the scenes, the event will be triggered, and I can watch all my activations, activation list in the background. to see what's happening. Yeah, the event hasn't triggered yet. So let me go on and just show you a little bit what's behind the composition while the event works. So I will click on this icon. Let me see if this. Okay, the workflow is small. I just want to show the code behind this workflow. What did I use to create it? And this is something that I really like and super excites me. A lot of workflow engines so far, they use their own language to describe, like learn an XML, learn a JSON, learn something new. Well, it's not the case here. Composer uses JavaScript. If I want to compose, I just say composer.sequence and I put something there. For instance, if I want to run the image, whatever I do the image quality, which should show here, is the image quality. I just create a sequence and I pass the parameters. What's neat about this model is that if I just need to do a simple JavaScript, or I just need to tweak a little bit, like for instance, just insert an extra tag that would say this was created with Adobe Runtime, which is our OpenWhisk deployment. I will just find it here. You see, I do result.tags.push, and I have my JavaScript code. I think this is really powerful. I can create basically, I'm not dependent on someone's language or definition, JSON schema or whatever to define any workflow. I can just do it with my code. All right, so let me get back and see what happened. Let me do the session list. Right, I have at least the composition that I executed. If I look in the session flow, I'll see some boxes. And a nice thing is that I can see the trace and how the request went. You see something grayed out on the right side, and you see something with blue. And the blue is the path that my script took, and the right is the path that my script did not take. Another nice thing is that if I roll over an action, in this case is the smart body crop in my composition, it gives me whatever the output of that action was, the X, the Y, the width, and the height to crop the image. And yeah, I can also, for instance, if I roll over the image quality, it will give me the scores. In this case, we do look at multiple scores: color harmony, depth of field. There's a bunch of features that we're looking at. And the end result, now let me show you the end result. So the image went through all this flow, and then it went into my assets. Let me refresh my assets. And I have to delete some. We're just playing with a swatch that's supposed to identify a piece of clothing, but it's not working. So allow me to delete it. You didn't see anything. And oh, my smart auto crop is not that smart.
Yeah.
AK.
Yeah.
Would you help me from here?
Yeah, I'm going to fix it. Would you mind if I come here? Okay. Thank you, Dragosh. Thank you, Sangeeta. How is everyone doing today? Good? Okay. So before I start, how many of you are familiar with machine learning or have some idea about it? Oh, wow. Quite a few of you. Okay. Now that we have seen the broken body crop from Dragosh, I'm going to show you how we can deploy, how we can test a model on our local system. And once we are convinced that it is doing a good job, we can deploy it on serverless. So I'm going to share with you Jupyter Notebook. In case you are not familiar with Jupyter Notebook, it is an open source tool that is used for visualizing and analyzing the data. And the model that I'm using today is basically called OpenPose. It is an open source model developed by Carnegie Mellon University. I'll be talking about it a bit later. So basically what in this demo I'm doing is, it is divided into two parts. First, I'm testing a model, and once I'm convinced that it is doing a good job, I'm going to deploy it. Now, the reason Dragosh body crop didn't do well was because it is rule-based. The rules are hard-coded to crop, and that's why it is not doing a good job. I'm going to replace those rules with an AI model, which is, in this case, OpenPose model. So let's start. So I'll run my first cell. What this cell is doing is basically it is importing all the important libraries like TensorFlow. The main action is happening in inference class here. And then I'm going to download the deep learning model called OpenPose. I'm downloading from Amazon. So I'll give the remote URL, and I'm going to download it. Just a second. So while it is downloading, just a second.
We actually saved it.
Okay.
I saved it before for the Wi-Fi.
Okay.
Yeah.
Okay, that's fine. Okay, so the model is already there in my local system. Now I'm going to show you the image that I'm going to crop. So this is the image that we are going to crop, right? This is the image that Dragos tried to crop and it didn't do a very good job. Now we can see this image and we can see where are the eyes, where is the nose, where is the shoulder, hips, and so on, because we are human beings, right? Let me show you how machine sees the body. So I'll run this cell. What is happening in this cell is basically my model is running in inference mode, and it is trained to detect body part. Now the version of model that I'm using, it is trained to identify 18 human body part. It is running in inference mode, so it takes around 9 to 10 seconds. Let's see what we have got. Okay, you can see that it has identified some body part, like it has identified nose, eyes, shoulder, and it has done relatively good job than what Dragos had. One thing to note here is that it has not identified all the body parts. So you can see that right knee it has not identified, ankles it has not identified, and that's okay. The thing with machine learning model is that it is not 100% perfect. Again, if you have your own data and if you don't want to use this open source model, you can train your own model, okay? Now, once my machine learning model has identified the body part in the image, I can crop it. So let's say I want to crop my image from eyes to hips. So that's why I have given the upper body part as eyes and the lower body part as hips. So I'll run this thing again. What it is doing is it is doing the same thing, running my model in inference mode. My model is returning the coordinate corresponding to different body part, and I'm using those coordinate to crop my image. So you can see that it has done a good job. It has cropped from eyes to hips. And you can see different stats also, like how much time it took to do that. Now, let me try to visualize the part of image that was cropped. So what I can do is I can draw a bounding box around the area of image that was cropped. I can do that by running this cell. Yeah. You can see that the part of image that is inside my bounding box, that is the area that was cropped. So that's just for visualization. Now let's try with another image. And this time, let's say I want to crop from eyes to elbows. So last time I cropped from eyes to hips. This time I'm cropping from eyes to elbow. So I'll change my parameters here. I'll give eyes and lower body part as elbows. I'll run this cell. And again, same thing is happening. My model is running in inference mode. It is identifying the different body part, and it is returning the coordinates corresponding to those body part. And again, it takes around 9 to 10 seconds. Now this time I have also printed the XY width and height coordinate you can see on my screen. And this is the new image that it has cropped. Now both this cropping I have done on the images that is present on my local system. Now let's repeat the same thing on a remote image. So for that, what I'll do is I'll give the image URL, which is my first parameter. And at the end, I'll give the same, the upper body part and the lower body part. So you can see I want to crop from eyes to elbow. Oops. Okay. Eyes to elbows. Okay. So I'll run this cell, and it will take again 9 to 10 seconds. Same thing is happening. Image is getting downloaded, and the model is getting run in inference mode, and things are getting cropped. Now you can see that it has done good job, but not very good. But that the reason may be because the person here is wearing sunglasses. The image resolution is not good. But I'm convinced that for my purpose, this open pose model is kind of a good model. Now up till here, it was all about testing the model, whether my model is doing a good job or not. Now I am convinced that it is doing a good job. The next step is to deploy this model in serverless. Now to deploy that, I'm going to write a file called smartbodycrop.py. Now this file is an injectable code that is injected on fly in Docker container, which is running inside OpenWhisk. Okay. So in this file, I'll write 4 parameters: model URL, the URL or the location of my model, the image URL, the location of my image, the upper body part, and the lower body part. And I expect that this code will return me X, Y, W, and H, these 4 coordinates from where I'm going to crop. Okay. So I'll run this cell, and you can see that it has written a file called smartbodycrop.py. Now, before deploying this code, let me test this file locally, whether it has done a good, like it is written properly or not. So I'm going to test this file by running using the model that is there on my local system. So we have not touched the serverless part yet. I mean, we have not touched the remote server yet. Everything is happening right now in my local system. So I'll run this cell, and it takes some time because my model was running in inference mode, and you can see that it has returned 4 parameters: W, H, Y, X, and then it also shows how much time it takes. So that means the file that I wrote, Smart Body Crop, it's a good file. That means it's ready to be deployed. Now, the easiest way to deploy anything on serverless is using Apache OpenWhisk shell. It is an open source tool which I'll be using for deploying the function. So I'm going to download this, and I'm going to install this by running this cell. The next step is configuring my Apache OpenWhisk credentials. So I'll put all my credentials in .wsk props file, which is here, and I'm going to run this cell. Now, deploying a function also expect that you have all the dependent Python file zipped and put in main.py folder, which I'll be doing that by running this cell. So, and of course, I have to specify where is the location of my model. Yeah. Now, you saw the smart body crop action that Dragosh showed, and it was broken. I'm going to update that action with all the necessary file and all the model that I tested on my local system. So I'm going to update my action, and you can see that it says updated. My action has been updated. So one last time, I'm going to check whether things like my action is up to date or not. So I can get the status of that by doing action get. So I'll run this cell. And you can see that, yeah, it's returning me all the proper output. That means my function has been updated properly. The last step is basically invoking the function, which is like making the function call. For that, I can do action invoke, and I'll pass the parameter like the URL to my image, the upper body part, and the lower body part. And I'll run this cell. You can see that it has returned a unique function ID. This function ID is associated with each unique function call. Now, for the first time when my model is running in the serverless, it takes some time. That's because it is downloading the model, it is warming the container because containers were cold. So it may take some time. In my case, it is taking around 40 to 50 seconds. I can get the status of what has happened to my function call by copying this ID, which is associated to my function call, which I did, and pasting it here. And then I can get the status of that. Now you can see that it is giving me error message, and that's okay. That means my function call has not completed yet. So I'll wait for some more time. Generally, it takes 40 to 50 seconds, but sometimes if things are running slowly, it may take, let's say, 1 minute or so. So I'll run this again. Yeah. So now you can see that it has done the proper job. It is returning me all the 4 coordinates that I was expecting. And you can get all the other stats also, like how much time it took to download the image, how much time it took to download the model, how much time the TensorFlow session was run, so on and so forth. Now, after I have made my function call, if I make my second function call before my container is recycled, you can see that response is almost instantaneous. Yeah. So you can see that it took only 1 to 10 seconds instead of waiting for 10 to 15 seconds. And that's the beauty of serverless. That's the beauty of OpenWhisk. Once your containers are hot, you can just like any serverful environment. So I want to tell you that me and Dragosh both worked on this, and the way we were able to collaborate and work on this demo, and the way we tested and deployed things, my experience as a developer was very good. And yeah, that is my conclusion for this demo. So from here, I'll ask Dragosh to take back.
Thank you, AK. All right. So let's see if of course how this function works in the real workflow. And I'm going to upload 3 images. AK didn't quite agree with me, but I was really curious. For those of you that saw Silicon Valley, I was really curious if we put a hot dog, what's going to happen to the algorithm? Will it explode or will it actually work? So I have this. Oh no, not where is the hot dog? I have the image of the hot dog. Well, not sure if you remember the show where there was this algorithm that was able to was all of a sudden able to just see the hot dog. So I'm going to put a hot dog. And actually, let me just put the first person. I get this guy. All right. And I'm also going to put our hot dog. And let's see what happens. Now that AK has deployed the function, I can go right now and put 1,000 images, and they will still work. I think this is a very nice thing with serverless. You know, it scales, and yes, it may not warm up so fast. You notice that first time you had to download the model and do those things, but it's so peaceful to know if I have a background job that in this case in just the images I can go from 0 to 1,000 images, and then I only pay for that, and then the system shuts down. And besides this, I really love the experience that I was able to, we were able to do together. Basically, AK deployed from the Jupyter Lab notebook, deployed his own a new model. So let's see how our models are doing here. So if I do a session list, I get this one 28 seconds, and this one is 9 seconds. So I think this is the hot dog, because it took fewer time. Oh. Let's see. I should find some traces, so just bear with me a little bit. Oh no, I don't have the image name. It was on top, right? Somewhere on top. Something with, yeah, hot dog JPEG. All right, so it looks like hot dog didn't pass the image quality, because the image quality is let me go in the session flow. It's only 54%, and we only let images are more than 61. So this is very interesting. So, anyways, the algorithm thinks that this may actually be a person. Who knows? A little, like very, very close. I don't know why. Yeah. So it didn't go on the path of doing the body crop and so forth. It just uploaded back the image into the Creative Cloud for the photographer, just to know it didn't go. So now let's go and see from my poor body crop algorithm, how does it look right now? All right, this is the person. Thank you very much, AK. You saved my day. And in terms of tags, let's look at some of the tags. So this is the one that I put manual, created with IR runtime, and it was able to identify its fashion, male, adult, so forth. You can imagine that you can train. If you have pictures, you can even train to identify the product SKU, but we just didn't have the data for this demo. And I think the possibilities are pretty much endless here. You can imagine any workflow you want. If you fall under this event-based workflow, and if the latency is not super important for you, then you can build workflows, you can deploy AI models right from Jupyter Notebook, and do this at scale. So to wrap it up, what have we seen? So we've seen that Software 2.0 entangles the model with the code, that we were able to use Jupyter Lab to assist us in the model development and functions to assist us in deploying the model, and that machine learning engineers can collaborate with software engineers. By the way, we're not here to say that everybody should use Jupyter Lab or that everybody should use Apache OpenWhisk, but it's just one workflow that we came up with to make it easy, to make it more to streamline how engineers can collaborate on this. And lastly, with Fast, it's easy to deploy a new AI model as a function. That's what we wanted to share today. So thank you very much for coming here. I'll leave you with some conclusions. Fast platform are still maturing, but we can make it faster to deploy AI models and build more services and pay less with serverless. So thank you very much.
Thank you, everyone.
Thank you, guys. Questions?
There's, okay.
Yeah, that is true.
Thanks for the talk, really awesome work. So I can see that with this approach, you can definitely iterate and move much faster. I wonder if there's any sacrifice from this approach in terms of the server stability and how to, for example, do testing of the code they wrote before you push, things like that.
Yeah, that's a very good question. So right now in our demo, the only testing done was in the Jupyter notebook. You just do Shift Enter and make sure it works. You can, to some extent, you can write some unit tests. For vision, it's quite interesting. How would the unit test look like? You will run inference and then you will compare the image, and yeah, it's still an open.
Yeah, not necessarily in the case of deploying a model, right? Because sometimes you will probably want to add some pre-processing or some business logic before or after you run this model, and those code you might want to add more testing. And even when it comes to the CV model itself, you might want to run it on some fixed data set or run it on some dark mode traffic to just observe for a while, see if it breaks, things like that.
Yeah, so I can answer this question. So in the Jupyter notebook that I showed, everything that I wrote, it was in a class, right? Inference class.
Yeah, bring it here.
Yes. So at the top, all the action everything that I'm doing, it's happening in a class. Now you can write your function, your own class, which is handling like all the use cases that you told about. So that's very easy to write. And the way we deploy things inside Adobe is, let's say I want to test first on, let's say 100,000 images, and I don't want to do it on my local machine. What I generally do is I deploy my model on stage, and then I test that on 100,000 images, get the result, and then once I'm convinced, I deploy it on my production. So all the use cases and all the error handling that you want to do, that you can take care of in your inference class, which I have written here.
We can talk more if you want. We
can talk more. Yeah.
I think there was a question in the back also, Sankita. Thank you. I think it was all the way in the back, right?
That was in this one here. All right.
Hi, thanks for the talk. My question is, do you know how often the functions are recycled? Like once they are warmed up, can they be recycled again?
They are, yeah. I would say it's configurable.
It's configurable?
I'm trying to come up with a number from Amazon Lambda, for instance. It's probably minutes. So
8 minutes or something, right?
I don't know exactly. Between 5 and 10, if I'm correct. Yeah.
Okay, so let's say another request comes in between the 8 minutes, and then is it gonna be again kind of expanded the time slot, or would it be
After?
Yes.
Yeah, you're gonna pay for the cold start, and this is indeed something that it's a trade-off. You pay for cold start, but you don't pay when you deploy. You only pay per usage. So yes, it's one of the challenges. Thank you for mentioning this.
How would deployment and versioning work? I understand that this is serverless, but what if we want to add, let's say, a couple more models to do some kind of A/B testing, and then we want to deploy a new version of the function, or we have a more complex system where we are using multiple models? Then, yeah, thanks.
Yeah, so I can give an answer. I'm not sure. Did you want us to take this?
So we had an action called smart body crop, right? So you can create your own action with something like Smart Body Crop version 1 action, Smart Body Crop version 2 action, Smart Body Crop version 3 action. And in those action, you have different version of models. Did I answer your question?
Like
Like,
when you create the action here, where was the code to create the action? I'll just get to it here.
yes.
I can even create a package, but I can also put body crop v1.
Yes.
And there's, I would say that versioning is not really I think there could be always improvements to how we solve versioning, but right now serverless platforms kind of offer this. I know in Lambda, for instance, you can you have the latest, and then you have other versions, and you can say my request on this endpoint should always use this version, something like that. Yeah, and because you see, if I name the function like v1, I also provide a model URL as a parameter here, so I can actually link a version of the model with a version of the action one-to-one.
How does serverless manage the dependency libraries?
That's a great question. Per function, so the answer is does not. It expects that if you have multiple libraries, you just create a zip and you upload the zip to the function. And we actually did this here.
Yeah.
I will just show you. Maybe we went too
No.
fast. It's right here. We actually created a zip because AK created some Python classes and
Yeah.
they had to be zipped together. So we created a zip.
So you can control actually which version of pip you are using, which version of TensorFlow you are using. So those things you can control. So actually, when we were doing this, there were some library called OpenCV. We tried to use something which is something like image PIL pillow library because of this license issues. So those things you can take care of.
That was a great talk. So I had a question about, so usually there's trade-offs with software development. So what are cases where this is a good idea to implement, or what are cases where this would be a bad idea?
Thank you for this question. Yeah, I wanted to put a table, and I missed. I once saw a slide from Adrian Crockford from AWS. So picture this: like serverless makes some choices for you for the frameworks. You just push the code. In this case, we use an action that has the version of the TensorFlow embedded in, and maybe other versions. With containers, you have full control over those versions. Second aspect, when you don't have a latency sensitive use case, like an application actually waits for an answer, I wouldn't use, I think, this unless my system behind the scenes figures out to use a predictive model to pre-warm my containers beforehand, which you can do. If you know you have traffic at 8 a.m. in the morning, you just send 1,000 requests at 7:50 or something, which you could do. But I'd say event-based and cases where latency is not critical for the application.
Anyone else?
I just want to understand how the decision of taking down that container is made on the cloud side. Like, if I would not want my container to be destroyed, I would like to be idle, and then run next time without needing to be warmed up again. But the other side, they have different objectives, right?
Yeah, that's a good question. Some people, I see even libraries on GitHub that work with Lambda, so that, let's say you want to keep 5 functions alive, so you schedule a function to run every 5 minutes to actually make those 5 invocations. What I do expect to happen, fast platforms are still maturing, but what I do expect to happen is that teams will work on a predictive model, and if your traffic can be predicted, then it will pre-warm ahead of time. And second, the performance of how long it takes to pre-warm a container should be improved by these platforms. For instance, let's say you deploy a lot of models. So have a serverless platform that would give you temporary storage that is very close to the action code, like an EFS, if you're familiar with this, Elastic File System from Amazon, or Network File System. So you don't have to download the model. So these things got to be made faster. They're not as fast right now.
So I can just artificially make a heartbeat kind of request to that container until Amazon kills me. Is that?
Yeah, actually, if you have traffic, so if you actually have traffic, the containers never die. They just spawn up.
Just a question. So I'm also new to serverless. So how portable are these functions between different cloud providers? Like if I wrote a function on like Lambda on AWS, can I move it to Azure clouds, Azure functions or Google functions, or I have to change my code significantly?
I think today you have to make some small changes, and I can try to show. Where was I with? This was the code. Let me see if I can make this bigger. Oh, I don't know how to make this bigger. Let me find the slide. It's usually in the input parameters. Where did I have the slide with?
So while you're looking for that, Ragosh, what about things like serverless framework? I thought part of their goal is to abstract the serverless platform away from it, right?
Thank you for this. Yes, so there's serverless framework, which is like a manifest where you can define at the function level code. In this case, with OpenWhisk, I only have one input object. With Amazon, Google Cloud Functions, and Azure Functions, you have a secondary object which is called context, and in the context you may have something else. So you might have to have a wrapper. Like you could write your function to work in all systems. That would be lovely. I call that library as a service. You know, you just for library, and if somebody needs, it's just deployable. But you have to write a little bit. But my hope is that these platforms will standardize on the input, and they will be more portable-ish, because every provider will try to make it easy to use. Like if you're in Lambda, you will have some pre-existing libraries which won't exist in Azure Functions or Google Cloud Functions. So that's why it's ish.
More questions?
What are the guarantees from Amazon on the data I uploaded there to run as a fast, so that this data is owned by me, so nobody should be able to, even Amazon should not be able to use it for any purposes to share or for commercial uses?
Correct. So in this case, we have uploaded our model in, we copied from an open post from Dropbox and actually put it in our own account in Amazon. Yeah, so if you train your custom model, you don't want to make it public. So yeah, you put it, in this case, I think you can use any blob storage. You name it.
So machine learning models are like a file, right? It can be stored in any secure environment. It doesn't have to be Amazon. For this demo, we uploaded our model on S3, but it could be anything. It could be Dropbox, it could be your own custom provider, something like that. So it all boils down to how secure is your platform where you are storing the model.
Did I answer your question?
No.
I'd say like if I were to make a choice right now, and we have to end up with this question. Thank you very much for highlighting that. I'd say if I were to make a choice, I would still use a object cloud storage. But there's a ton of them like this, 20, 30, and we use a tool that is called, I will show you. I use a tool that is called rclone, and I'll real quickly. You see a list of object cloud storage that it works with. So you can actually make something generic and upload it anywhere you want, and then just pull the model from there. You should have security there. It's fine. Yeah.
I guess that's orthogonal to serverless, I would say, isn't it? But anyway. Yeah. Sure.
Yeah.
All right.
We can talk more if you want.
Yeah.
Well, thank you both of you, and they're here if you have more questions. Thank you all for coming.